Hi everyone, welcome to my coding channel, Coding Learner. So today we discuss about the circular linked list. So it is similar to our previous linked list which we implement in our previous videos. So there is only in our linked list. So in our previous linked list videos, we points the last node to the null. So there is a difference over here. The last node is points to the head. So let's move forward. You can see that we are inserting our new node to our circular linked list, and we see that our last node points to a head. So I take a random addresses because we are working on a linked list, and in our linked list the memory will be allocated dynamically. It means that it is not continuous memory, it is non-continuous memory. So thus I takes the non-continuous addresses. When the addresses are continuous, it means that we are creating our array. So to take a little bit different, we are taking the random addresses. So the at the insert at tail, first we create a new node, and let's take name it as n, and we are creating a temporary node which points to our head initially, and it's run until and unless a temp to next is our temp to next is not equals to head. And when we find that we are placed at the last node which points to our head, and here our temp next will be point at a new node, and our new node point to a head. So this is how the insert at tail will complete. So now the linked list is look like that. First we put our temp next to our node, and then our new node next will point to our head. So this is how insert at tail will done. Let's move forward. So now we are code for our insert at head function. There is a head over here. So I created temp a new node. Let's take it as n, and I create a temporary node which points to head initially, and it runs until and unless a temp next is not equals to our head. When it comes at the last node, what we are doing, first we take the temp next to a new node because it is our head now. Thus we first take this step because our circular linked list, our last node will be point at head, and then our and next will be point ahead, and then we place it here, and we call that our head is our new node now. So this is how our insertion at head is goes. And now we discuss about the insert at position. What if we want to place our new node at the third position? So first we check if there is a one condition over here. If our head is equals to null, then we placed a new node to our head. So there is, if our position is equals to 1, then we call our insert at head function and then return, because we need to place the node at the first position of our linked list. And I created a new node with name as n, and we initialize our counter, and there is a temporary node which initially points to our head, and the loop will be run until and unless our temp next is not equals to head, and so now our temp will be point at our head, and initially our count is 1, and when we goes inside our loop, then our count will be incremented, our temp will be our temp to next. So this is how we find our last, how we find our node which where we need to be insert our new node. So here our count will be 2, and we want to insert at the third position, so it takes our previous temp temporary node, and then if our temp next is equals to head, if it is means that if our we want to insert our node at the end of the circular linked list, then we call our insert at tail function and then return. And if it is not, it means that we insert our node at a particular position between the nodes. So here our and next will be point to our temp to next. So this is our the line saying that our new node next will point to our temp to next node, and our temp next node will points to our new node. So this is how the insertion at a particular position will be done. It is the first step and then second. So this is how the insertion at position will done. And what if we want to delete our node from the tail in our circular linked list? So we create a loop until unless a is temp next to next is not equals to our head, because we want a previous node, and then our created a to delete node which points to our temp next, and then our temp next contains the address of our head, and then we delete a to delete node. So this is how the delete at tail is run. So that's it. For more shorts, please like, share and subscribe. So now we implement our circular linked list. So the structure of our node is similar to the previous node of our linked list. So now we define our insert at tail function, which takes our head as well as the value to be inserted at our node. So first of all, I created a node star new node which takes the value of our will, and if our head is equals to null, then we call our new node is our head and then return. If it is not, then I created a node star temp, a temporary node which is initially points to our head, and there is a while loop which goes until and unless our temp next is not equals to our head, and then our temp will always be our temp next node. If we find that we are at the end of our linked list, then our temp next will point to our new node, and our new node next will point to our head. So this is all about the insert at tail function. Let's move forward for the display function. If our head is equals to null, then return. If it is not, then we created a node star temporary variable which initially points to our head, and there is a loop which runs until unless our temp next is not equals to null. And we having an out statement which display our node data, and each time our temp will be our temp next node. And there is one more left node which is our last node, so I like to write here and then cout, and so this is the display function. I already created a head node which is one, and in our head next will be our head, and I call the insert at tail function 2 times by inserting 2 and 3 in our circular linked list, and then we call our display function by giving a head argument. So let's move for the testing. Just a minute. There is a dampness is not equals to null. Temp not null here is head, because we implement our link, not a linked list but a circular linked list. So we have to know that our last node will always be point our head, not null. So that's it about the display function. Let's run it. Okay, we get the output. So now we code for the insert at head. I created a node star n, a new node. Well, so we are inserting our node at the head position. So what we are doing, we first create a node star temporary variable which initially points to our head, and now our head will be our, not now, let's run a while loop which goes until and unless our temp next is not equals to our head, and each time our temp will be our temp next. If we came at the last node of our linked list, then our temp next will be point at our new node, and our head will be our new node. There is a one more step that our and next will point to our head, and now our head will be our end. So this is what the insertion at head will describe, define. Insert at head function, we call our insert at head function, and then head, and let's take a 0 at the head of our linked list. Let's run. So as you can see, our 0 index are placed at our head position, and now our head is our 0. Now let's move forward for the insertion at a particular position. So first we check if our head is equals to null, then our head will be our new node, and then return. First we create a new node by giving a name as n and call a node structure, and the argument will be our variable or a value. So if it is not, then we check if our position is equals to 1, then we call our insert at head function by giving our head as well as the value as well as our return. If it is not, then I initialize our counter by 1, and there is a node star temp node which is initially points to our head, and we are creating a while loop until and unless our temp next is not equals to our head, and our count will be smaller than a position minus 1. So each time our temp will be our temp next, and our count will be incremented each time. So if we are checking if we are at the end of our node. Let's take here next temp to next node, not next, let's take just next. If our temp to next is equals to our head, then it means that we want to insert our node at the end of the circular linked list. Then we call our insert at tail function by giving our head as well as the value, and then return. And if it is not, maybe we want to insert our node at the middle of the circular linked list, then we create a temp or, and next will be our temp to next node, and our temp next will contain our n. So that's it about the insert at position. Let's call it insert at position. I give a head, and there is a 5 over there, and first we place our first node at the end of the linked list. So we want to place it at a 5th position. Let's run. So as you can see, the 5th node will be placed at the 5th position. Let's take here 1. So now our 5th, just a minute, it is a position, it is a value, not a position. So we want to place our 5th data at the head of a circular linked list. So as you can see that our 5th number will be placed at first in the head, and let's take the position 3. As you can see that our 5 node will be placed at our 3rd position. So that's it about the insertion. Let's move for the deletion. We want to delete a node at the end of the linked list, so we could create a node star temp which initially points to our head, and there is a while loop which goes until and unless our temp next is not equals to our head, and each time our temp will be our temp next. If we find that we are at the end of the linked list or circular linked list, so we call our node star to delete node will be our temp next node, and our temp next node will points to our head, and we delete our
to delete node. Just delete it to delete node. So this is what we are doing. Just remove it first, insert at a particular position. So let's delete at tail function. We are calling delete at tail function, and we're expecting that the delete node will be either this one which contains the 3 value. Let's run. So as you can see, the last one node will be deleted from our linked list or a circular linked list. Let's move forward for the delete add head function. For there is one more base condition. If our head is equals to null, then return. If our head at delete function contains this value as well, if our head is equals to null, then return. If it is not, then we save our head at the to delete node for the deletion, and we create a node start temp which initially points to our head, and it's run until and unless our temp next is not equals to our head. Each time our temp will be our temp next. After that, when we are come at the end of our linked list, then we point our temp next will be our head next, and then we delete our to delete node. So let's save and run. Delete at head. Let's take a delete at head. Delete at head. So we are expecting that the 0th, just a minute. So we are expecting that our 0th node will be deleted, which contains the 0th value. Let's run. Just a minute, it's giving you the values. So I forget to write that our head will be our head next now. Let's run. Okay, when you can see that the 0th value which is present at the head are deleted now. So that's it about the delete at head, delete at tail, and delete insert at position, insert at add head, and insert at tail. Let's move for the delete at position function.